Alright, this is a little summary of the oxidation rules. So elements, meaning not compounds. So elements would be like oxygen, which is O2, magnesium. So elements by themselves always have an oxidation number of 0. Group 1 and group 2 always, unless they're elements, meaning by themselves, they always have an oxidation number of +1 and +2. +1 for group 1, +2 for group 2. Hydrogen. On the PowerPoint it says it's always +1. It's usually +1. The exception, even if you're following the PowerPoint, for example, sodium hydride. In the PowerPoint rules, the most electronegative element, which would be hydrogen in this case, actually that wouldn't be the case. In this scenario, though, obviously we're going to have the oxidation numbers add to 1, or add to 0 because there's no charge. In this case, hydrogen takes on a -1, while sodium being a group 1 is +1. So unless it's some weird thing like this, hydrogen is almost always +1, unless you see it as the anion. Oxygen is usually -2. The only time you don't see it as -2 is if it's a peroxide. A peroxide is in the form of R. I should use X, but Wikipedia uses R, where R is some random chemical. The most common peroxide is hydrogen peroxide. It's this formula, or H2O2. There will be dots around it, but usually they omit the dots. In which case, there's a single bond between oxygens. You'll never encounter this example. Even then, I say ignore this example. Let's just replace this with always. Fluorine is always -1. And we can ignore all the exceptions because we're not going to encounter them. Those are very weird chemicals that are extremely dangerous, and none of y'all will ever encounter, or hopefully y'all never encounter any of them. So, what is the oxidation numbers for all these inside here? So, what is Na? What group is Na in? Sodium. 1. So, it gets +1. Oxygen. Set it, let's always assume it's -2. In fact, you can go through this whole thing and put -2 for all the oxygen. So, what must Cr be? So, we have 2 sodiums. Each of the sodiums is +1, so we got 2 times +1. And Cr, which I'll let be X, we got 4 oxygens, and oxygens are -2, and all this must sum to equal 0. So that'd be 2 plus X minus 8 is equal to 0. 2 minus 8 is -6. So what must X be? +6. So again, oxygen is -2. What is potassium? +1 is in group 1. And what is chromium? I think that's chromium. You sure? So it is 6 plus 6. So -2 times 7 is -14. 2 times +1 is +2. So those two gives us 12 minus 12. And that means we have 2x minus 12 is equal to 0. Our 2x is equal to 6. And x has to give us, 12, has to give us +6. So what is carbon? +4. Now, this one, it looks like a hydride exception. But again, hydride is going to be very rare. It's not. Hydrogen is going to be our +1. You can almost guarantee that's going to be a +1 whenever you see hydrogen. So it only becomes a hydride when it's mixed with group 1 and group 2. Basically, group 1 and group 2 is a stronger rule than hydrogen rule. So it's not bonded with a group 1 or group 2, so it must be +1. That means carbon is what? -4. Remember, carbon can either be +4 or -4. This is not ionic, so it's not really giving up 4 electrons or gaining 4 electrons. But oxidation numbers or oxidation states assumes what if it was truly ionic. So what would so oxygen is -2. What would hydrogen be? +1. And what would chlorine be? What would it be, Allie? So hydrogen is +1. And so we have 1 plus 1. There's 1 chlorine. And we have 4 -2 charges for the oxygens. That would be 1 plus x minus 8, and that has to equal 0. 1 plus -8 is -7, which means x has to be 7 plus 7. What would manganese be? So we have manganese plus there's 2 oxygens, and each of the 2 oxygens is -2. That'd be manganese plus a -4 equals 0. So 4 plus -4 is 0, so that has to be +4. What would sulfur be in sulfite? It is +4. Now we have the charge sum to -2. So we have sulfur plus 3 oxygens has to equal -2. So sulfur minus 6 equal to -2. Add 6 to both sides. We get sulfur is equal to plus 4. What would fluorine be? Minus 1 is the most electronegative, which means sulfur must be plus 4. What is the range of oxidation states for carbon? You would want to express it as a range, but you're somewhat going on. A range is from the two, from this to that. So the lowest oxidation number a carbon can take is -4. The largest oxidation state carbon can take is plus 4. You can never get plus 5 carbon, at least that I know of. So what's an example of carbon with a plus 4 state? CO2. What about carbon with a -4 state? CH4. What is CH4? What chemical is CH4? This is an important one to have memorized. I never told you I really memorize it. It is methane. What is methane? What is it used for? What is the proper name you probably called it your entire life? Any of y'all have natural gas hooked up to your house? It's natural gas. What do we use it for? Why do we use it? And what happens when it burns? So, burning methane equation. So, this is just a tidbit. We are going from CH4 mixed with oxygen, and we're going to CO2 and oxygen. What type of reaction is this? Combustion. You are combusting the methane. What is the state of carbon here? Oxidation state on carbon. And you literally, what is it? -4. And what is it on carbon dioxide? +4. So its oxidation number is increasing. So it's doing what? It's being oxidized. Oh, another little thing about oxidized. What are we actually adding to carbon at the very end of the result? We're taking carbon and oxidizing it. When we oxidize it, we're actually adding oxygen to it. Usually when you add oxygen to something, it's being oxidized. But do y'all remember what happens when I told you when something becomes oxidized, what's released to? One is electricity, but in this case, we don't care about electricity. Energy. Because carbon is going from -4 to +4, this releases lots and lots of energy. It's the reason we use methane to heat our houses and a lot of fuel sources. Gasoline is more efficient But gasoline has carbon going from -4 to +4. There's multiple carbon atoms going on. This is only one carbon to one carbon and being changed. But this is actually the reason why natural gas or methane is used to heat up our house. It's because we're oxidizing the carbon significantly. It's going from a -4 to a +4. It releases a ton of energy. Enough to actually heat up an entire house. Alright, so here we have nothing but nitrogen we're going to be looking at. Nitrogen has 5 valence electrons. It can gain up to 3 electrons for a -3, or lose up to +5 electrons for a +5 oxidation state. This also answers the question right here. What is the range of oxidation states for carbon? Carbon has 4 valence electrons. It can either lose those 4 or gain 4. That tells you the possible states. So the range of numbers for nitrogen will be from -3 to +5. Do you get anything outside of that range? It's wrong. What is NH3? What? Yeah, it is. What is the name of NH3? This is one of the ones I told you y'all need to memorize. You need to have memorized NH4, negative, and NH3. CH4 is another good one to have memorized. But this one in particular, and acetic acid, but I'll admit I occasionally forget the formula for acetic acid. There's just too many C's and O's. Ammonia.
I thought ammonia was NH4 positive, so it's down positive.
It has ammonium.
Oh.
So this is ammonium. It's the ion version of ammonia. And this is ammonia. The IUM refers to the fact that it's an ion. So what is the oxidation state of nitrogen and ammonia? -3. Again, we're going to assume hydrogen is always +1. That means N has to be -3. Nitrogen. What's the formula for nitrogen? Nope. It's most definitely not N. What is nitrogen? It's an element on the periodic table. You're very off today. N2. It's a diatomic element. It never exists by nitrogen by itself. It's always N2. Just like oxygen is O2. So what is the oxidation state for nitrogen? 0. It's an element. Nitrite. So NO2, because the 8 version of it is not sulfur or phosphorus. So that means the 8 version is always O3. Ite means removing oxygen. And what would the charge be? Negative. What is the oxidation number? Mm-mm. So we have nitrogen plus 2 oxygens will all have a -2 charge. That has to equal the charge of the ion, -1. So nitrogen minus 4 has to equal -1. I add 4 to both sides. What is +4 minus 1? What is 4 minus 1? What is this called? Nitrate. It's the O3 oxy-ion of nitrogen. So it's an 8. And what is the oxidation state? +5. So the trick about 8 are oxy-ions. The 8 version, the non-oxygen part of it is the oxidation state is equal to the formula or the group number, unless it's a halogen. And then it's this group number -2. Besides doing that, we could do the same thing. That'd be -6. So n -6 has to equal -1. So we get 6 minus 1, which is +5. Dinitrogen monoxide, what's its formula? N2O. And what is the oxidation state for the nitrogen? +1. So we need 2 plus charges to counteract the -2 for the oxygen. Again, these aren't charges, these are oxidation states, but they're very similar concepts. NO2. What's its name? Nitrogen dioxide. Anyone know the other name of it, the more common name? Laughing gas. Or nitrous oxide. What is the oxidation state on the nitrogen? +4. So we have 2 -2 charges to counteract it. We need a +4. Hydroxamine. This is where we're getting to more organic chemistry that has its own different naming scheme for it.
Okay, -1.
It would be -1. So we have 3 oxygen. I think it's a +1. Oxygen is a -2. And we get nitrogen plus that is equal to 0. So that'd be 3 minus 2 is equal to 0. So that'd be n plus 1 is equal to 0. And moving it over, n minus 1. Assuming all the hydrogen is +1 and the oxygen is -2. Nitrogen has to be -1. Nitrogen monoxide. And what's the oxidation number? +2. To counteract the -2 on the oxygen. Hydrazine.
+2.
New. So hydrogen is +1 always.
And there's 4.
So it should be -2, right?
Oh, yes.
To counteract all those positive charges, it has to be minus. So during chemical reactions, the oxidation state of an atom can change. This occurs when compounds gain or lose electrons or when the bonds to an atom change. This is illustrated by the reaction between nitrogen and hydrogen to make ammonia. So what is the oxidation number for N and N2?
0.
H and H2?
0.
So these are elements. Single atoms are only one type of atom. What is the N in ammonia?
-3.
You can just look up. What is the H in ammonia?
+1.
So when the oxidation number increases, it's being oxidized. So what reactant undergoes an increase in oxidation number? So by the way, on the left-hand side of an equation, it is called reactants. Each of these are called a reactant. On the right-hand side is called the products. So it's asking which of these two on the left-hand side is being oxidized or increasing in oxidation number. So which is it? Which one's increasing? It would be H2. And which one is decreasing? Has to be nitrogen. So the species that's oxidized is called the reducing agent because it gives up an electron. So what is the reducing agent? The thing that reduces something else or the thing being oxidized. Yes, it would be hydrogen. And what is the oxidizing agent? Hydrogen. So hydrogen is being oxidized. In which of the following in each of the following reactions, assign oxidation numbers to all the elements and identify by the oxidizing and reducing agents and the change in oxidation number. So what is the so let's go through and do the numbers. What would iron be? What is the oxidation number on iron? That should be instantly telling me. What's the oxidation number on iron? This isn't no calculation or anything. Is it an element by itself?
Oh, 0.
0. Oxygen, elemental oxygen. 0. O2 is an element. What about iron here? +3. This is iron 3 oxide or rust. And oxygen? So what is the oxidizing agent? Iron is what's being oxidized. The oxidizing agent is obviously oxygen. It oxidizes something else. Makes sense why it's called an oxidizing agent. It's going to cause iron to increase its oxidation number. So it's the agent causing it. Oxygen is an oxidizing agent. In almost all cases, unless you deal with fluorine, it's going from 0 to -2. So what must be the reducing agent? It's going from 0 to +3. It's being oxidized. Chromium, what's its oxidation number?
+6.
Yes. So we have 2 chromium. with 7 oxygen that has -2 charge. And that has to add up to be equal to the charge of the ion. That'd be 2 chromium minus 14 has to equal -2. Add 14 to both sides. That's 2 chromium is equal to 12. Divide by 2, we get +6. And the oxygen must be? -2. Oxygen and hydroxide? It's always -2. You can ignore all the exceptions. Hydrogen is +1. You can ignore all the exceptions for this test. What is chromium on this side? +6. What is oxygen? -2. +1 and -2. So where's the oxidizing agent? There is none. Did any of the oxidation numbers change? There was no change in any oxidation numbers. What does that mean? It means this is not a redox reaction. Point is, don't just assume oxygen is the oxidizing agent. You actually need to check. Alright. So, what is the oxidation number for nitrogen here? This one is a little tricky. So, what is NH4NO2? What does this immediately scream, should scream to you what this is? I'll give you a hint, this is more complicated. You have to do something different about this one. So, NH4NO2. This should immediately scream to you ionic compound. Here is ammonium. It's an ion. It's the only polyatomic ion. That means we can split this into 2 ions. NH4 with what charge? Plus. It's the only polyatomic. NO2 must therefore be NO2 negative. Now let's solve this problem for the ions. What must the charge be on the nitrogen here? You did it in the wrong way. So we have N plus 4, and the hydrogen will have +1 charges. And it has to equal +1. So subtracting 4 from both sides, we get nitrogen is equal to -3. So this first nitrogen is -3. Hydrogen, we use +1 in it. What about this nitrogen over here? Same thing. Nitrogen plus a 2 times -2 has equal -1. So I'm going to subtract 4 from both sides. I get nitrogen is equal to, not subtract, I'm going to add 4 to both sides. 4 minus 1, I get +3. And then oxygen would be -2. So recall this fact that oxidation is treating all the bonds as if they're ionic. So when we look at something like methane, methane is not ionic, but we're going to assume it is. And if it is, then the oxidation number is can be thought of as a pseudo charge. If it is 100% ionic, then the oxidation number is the charge. If it is ionic and we're assuming it's ionic, or if we're assuming it's ionic and it's already ionic, there's no need for assumption. There's no need to assume anything. Its oxidation number will be it. So if you see something like this, you can break it up into ions. If we get, like for example, NaF, this is an ion. What do we know about charges? We know this is -1 and this is +1 charge. Or I should say, I should more do it like this. This produces Na plus ions and this produces F negative. So the oxidation numbers will equal the charge because there's no need to assume. Water, however, is not ionic, but we can assume it is and make this a -2 and these +1s. This isn't ionic, but if it is ionic, the oxidation number will. For this scenario, the only way to solve it is realizing the fact that you should break it up and analyze it on like this. Does that make sense? So what is nitrogen? 0. And I basically just did it here. +1 for hydrogen and -2 here. So what is the oxidizing agent? In this paper, it's wanting you to list the agent from the reactants. The reactants would be NH4NO2 and NH4NO2. My answer key just has this note on it. The nitrogens are in different states. So something can be both an oxidizer and a reducer. You can have a single chemical that is both an oxidizing agent and a reducing agent. So my knowledge of chemistry tells me that this is probably heck of explosive. I'm curious. Do y'all know what this is? What is the name of this? Nitrite. What was the? Do y'all remember when I looked up bombs?
I don't know.
I looked up. I told you that the reason why oxidizings are important is they release a lot of energy, and they're used in almost all the bombs. This is ammonium nitrate and ammonium nitrite are the two most common explosive compounds. Terrorists and like bombers, like the Unabomber, and anyone that does it makes it out of. It's a fertilizer too. But nitrate is more stable. Nitrite is highly unstable. Do y'all remember the explosion in, where was it? It wasn't Egypt. It was on a dock. Was it Egypt? Oh, it made headlines like a few weeks ago. It was in Beirut. Yeah, I don't remember that. In Lebanon. So it's a common fertilizer, ammonium nitrate, not nitrite. Nitrite is too unstable. Where is it right before it explodes?
A major emergency situation unfolding was a short while ago. There was a massive explosion.
So what happened was a shipping container was seized. They didn't pay their docking fees, or they didn't pay some fee or something. And so they unloaded all this fertilizer, ammonium nitrate, and they put it in a warehouse. And because it can oxidize itself and reduce itself, what does that mean? It means it can spontaneously just produce a ton of energy. Whenever something is oxidized, energy is released from the result of it. So here is what happens. And that's in the middle of a giant big city.
It said that there may have been a problem at a fireworks factory, although things of course have not been.
So anything that is a self-oxidizer is very, 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 very dangerous. The fact that this can spontaneously oxidize itself means that you should treat it with extreme care. Don't stockpile large amounts and put it in a warehouse, especially in a crowded city. Any basic chemistry teacher should be able to explain that to you. Why in the world the brute government? I looked at it. There was a lot of regime changes going on, a lot of issues that was pushed back, but the whole situation should have been easily avoided. You do not stockpile ammonium nitrate in large quantities, especially in a densely populated city. So for the oxidization agent, the oxidizing agent is going to be so the one that is being reduced. The one being reduced is this one. It's going from +3 to 0. It's oxidizing this one. This one is going from 0 to +3. So phosphorus, what's its oxidation state?
Yeah.
Chlorine. Phosphorus here. Or what about chlorine? -1. Therefore, phosphorus must be +5. So chlorine is the oxidizing agent. Is being reduced from 0 to -1. And the reducing agent is phosphorus. It is going from 0 to +5, so it's being oxidized. these last examples, I wanted to cover half reactions. Unfortunately, no, these do that, but we're running out of time. Some of the very end, keep these, we'll do it, and y'all need to get those research assignments today. I can put the free 100 in the grade book.